Almost every human alive today carries fragments of an extinct species biologically, written into chromosomes, shaping immune systems, sleep cycles, reactions to cold and disease. The extinct never disappeared. They became part of us. But some populations carry almost none of it, not reduced, nearly absent. Inside that absence lives a survival story older than any civilization ever built. 70,000 years ago, small groups left Africa during violent climatic instability. Corridors opened and vanished within a generation. Beyond Africa, they met the Neanderthals, adapted to Eurasia for hundreds of thousands of years, shaped by pressures Homo sapiens had never faced. The two populations reproduced together, repeatedly. That evidence still lives inside billions of people. Except, not everywhere. Some African populations carry little or no Neanderthal ancestry, which raises a disturbing possibility humanity may have survived not through one unified expansion, but through fragmented populations enduring completely different pressures. Drop a comment. Where are you watching from? And what kept humans alive during the Ice Age? Intelligence, cooperation, violence, or simple luck inside a collapsing world? The prehistoric world was never densely populated. It only feels that way when looking backward through 10,000 years of written history. There were extended periods when all Homo sapiens may have existed as scattered bands, totaling only a few thousand individuals across enormous territory. Humanity was fragile from the beginning. A failed hunting season, a disease, a generation with too few surviving children, any of these could erase an entire lineage permanently. The ancestors of most non-African humans passed through a narrow demographic bottleneck near Northeast Africa before expanding into Eurasia. That bottleneck forced contact. Small migrating bands repeatedly entered territories already occupied by Neanderthals, and the encounter was not one dramatic collision. It was a slow system unfolding over thousands of years, across shared rivers, competing hunting grounds, and occasional reproduction. But many African communities remained outside those northern contact networks, shaped by entirely different pressures, different disease ecologies, different climate regimes, different demographic mathematics. The clearer pattern becomes connectivity increases adaptation, but it also spreads collapse. For a long time, extinction was imagined primarily as violence, one species defeating another in some decisive confrontation. But ancient DNA reveals something far colder than that. Extinction can happen mathematically. A population does not need to become weak or inferior to disappear. It only needs to become too small for too long, until randomness itself finishes the work. The Neanderthals may have been living inside that pressure for thousands of years. Genetic evidence points toward repeated bottlenecks, shrinking diversity, and isolated communities increasingly vulnerable to catastrophe. One harsh winter, one epidemic, and entire branches of a lineage that had survived 300,000 years simply vanished. Meanwhile, Homo sapiens carried something less visible, but more consequential, not superior intelligence or weaponry, but superior connectivity. Population structures spread across enough territory that no single catastrophe could erase all of them at once. That may be precisely why some populations today carry almost no Neanderthal ancestry, not because they were separate from humanity, but because they survived through a fundamentally different architecture. Human evolution stops looking like a ladder. It starts looking like multiple, fragile systems, each trying not to collapse at the same time. The deeper ancient DNA research goes, the stranger the full picture of humanity becomes. The Ice Age world was populated by multiple overlapping human lineages: Neanderthals, Denisovans, Homo sapiens, and possibly others science has not yet identified. These groups exchanged genes, repeatedly, across deep time. Modern Melanesians carry high Denisovan ancestry. Most Eurasians carry Neanderthal ancestry. Some African populations may preserve traces of contact with unknown archaic groups within Africa itself. The old framework of clean, separate human lineages has collapsed. Human evolution was adaptive and opportunistic, driven by contact as much as isolation. Fragments of extinct populations may have helped later. Humans survived diseases and ecological extremes their purely African ancestors had never encountered. But groups remaining deeper inside Africa experienced profoundly different pressures across timescales that dwarf recorded history, rainforest expansion, desertification, shifting disease ecologies. Because of that, some populations preserved a far weaker Neanderthal signal, not an untouched or original humanity, a different migration history, a different survival geography entirely. One of the strangest parts of this story is that Neanderthal DNA was not always beneficial. Some inherited variants appear linked to genuine advantages, improved immune responses to pathogens outside Africa, cold weather metabolic efficiency, skin adaptations for lower sunlight environments. But others are associated with elevated inflammation, increased depression risk, and severe immune overreaction. An adaptation critical for Ice Age Eurasia can become a liability in an entirely different world. There was never a single, perfect evolutionary pathway. Large, interconnected systems generate adaptation, but they create synchronized fragility where a single pressure can bring down many components at once. Smaller, isolated systems preserve continuity, but risk disappearing through demographic attrition. Humanity may have endured because both systems existed simultaneously: expansion and refuge, contact and separation, reinforcing a network that no individual group could fully see. Modern racial categories collapse almost immediately when placed against the ancient DNA record, and the collapse is illuminating. Two people from sub-Saharan Africa can possess more genetic distance between them than exists between entire populations from Europe, Asia, and the Americas combined. That single fact reveals how deep and old the African chapter of human history really is. Homo sapiens evolved there for hundreds of thousands of years, before smaller branches expanded outward. Non-African populations represent only a subset of a far more diverse human reservoir. During those outward migrations, some branches encountered and absorbed archaic populations. Others did not. That is why the phrase "almost no Neanderthal DNA" is so easily misread. It does not signal proximity to some purer humanity. It signals a different migration history, a different pathway through the Ice Age world. And the most haunting implication inside the ancient DNA record is how many populations vanished without a trace. No descendants, no preserved bones, no memory carried forward. For every lineage researchers can still detect, others disappeared so completely that the species no longer holds any record they existed at all. The farther researchers push the reconstruction of prehistoric migration systems, the more human evolution resembles climate rather than conquest. Populations expanded and contracted like weather patterns responding to invisible pressures. Grasslands temporarily connected continents before deserts severed them. Sea levels fell and exposed migration corridors, then rose and drowned them within a few thousand years. Survival depended less on individual heroics and more on whether enough populations remained connected to recover after catastrophe. That distributed quality may be why Homo sapiens endured, while other human lineages disappeared, not because modern humans were destined to survive, but because extinction pressure was spread across enough separate populations that no single event could be a final one. Some groups failed, others survived elsewhere, carrying enough information to rebuild. Hidden inside populations carrying little Neanderthal ancestry may be evidence of one of those preserved reservoirs communities that held their ecological position while populations elsewhere collapsed, preserving genetic diversity that would have been permanently lost if the entire species had passed through the same bottleneck. Diversity was not an aesthetic property of the species. It was anti-extinction infrastructure. Some researchers now suspect that genetic exchange between human populations was not exceptional, a recurring feature of how Homo sapiens operated whenever separated groups reconnected after long isolation. If that is correct, much of human evolution happened at contact zones, at boundaries, at moments when migration systems collided under shared ecological pressure. The boundary between Africa and Eurasia may have been one of the most consequential biological frontiers in history, where populations carrying hundreds of thousands of years of divergent history suddenly shared resources, climate pressures, and in some cases, reproductive networks. Climate instability pushed populations through that boundary in both directions. Some entered Ice Age Eurasia and encountered Neanderthals in the Levant and the southern Caucasus. Others remained farther south. Some later carried traces of those encounters back into Africa through back migrations. The ancient DNA record is only now beginning to make legible. Even now, genomes carry faint echoes of those movements, not as clean lines, but as probability distributions, partial signals, statistical ghosts of systems that operated for thousands of years before the world changed again and dissolved them. The most unsettling realization inside this research may be how contingent all of it was. A drought lasting an extra decade, a colder century arriving at the wrong moment, a child surviving an illness that killed everyone else in a small group, a band choosing one valley instead of another, redirecting the genetic future of an entire continent. The people alive today are not the inevitable product of evolution. They are surviving fragments of an enormous prehistoric filter, one with no preferred outcome, that eliminated most of what passed through it. Most human stories ended quietly, within a few generations, without anyone left to register the loss. The woman at the Ranis cave site in Germany, 45,000 years ago, whose ancient DNA places her inside a small family, moving through a landscape that should have killed them, she survived. Her distant cousin at Zlatý Kun in Czechia survived. The thread held, but the thread was narrow, and the forces working against it were not. The human body is filled with molecular memories from populations that came close to permanent disappearance. The Neanderthal percentage preserved in billions of living genomes is a record of a species that did not survive, one that left only a fraction of itself inside the people who replaced them, a quiet measure of how close the boundary between continuation and extinction can be. The discovery that some humans carry almost no Neanderthal DNA does not divide the human story. It reveals how many different survival systems once existed simultaneously within a single species across timescales that human intuition is not built to hold. Some populations survived through contact, absorbing genetic material from archaic lineages. Others survived through depth, preserving internal diversity accumulated across hundreds of thousands of years in the continent where the species originated. Together, they became the modern human world. But the larger lesson may have nothing to do with Neanderthals. The prehistoric world was filled with intelligent, tool-using humans who still disappeared. Technological sophistication did not guarantee survival. Ecological adaptation did not. Everything depended on whether populations remained resilient enough when environments shifted faster than their systems could absorb. That pressure did not end with the Ice Age. Modern civilization feels permanent because its networks are vast food supply chains, energy grids, global infrastructure. But vast systems carry their own vulnerability. They can become fragile in ways smaller populations never were, because their interconnected components allow pressure to propagate farther and faster than any node can respond to. The Ice Age humans in those narrow survival corridors could not see the invisible systems controlling whether they lived or disappeared. Most humans inside modern systems cannot either. And maybe that is what ancient DNA keeps surfacing, not just a record of who we are or where we came from, but a quiet reminder of how narrow the margin between continuation and silence may always have been. If this is what you came here for, the deep systems, the demographic pressures, the questions the bones and the genomes are still only half answering, then Prehistoric Shadows is where you stay. Subscribe. The next one is already waiting.